Hello guys, we're going to be learning something very sweet. Guess what? I'm going to be taking you on every singular thing you should know under your indices. So I want you to sit down. Mathematics is not difficult. It's just your ability and your willingness to sit down and follow me. That's all you need. Now, I want you to know that this is the first lesson we're going to be taking on indices. There are a series of lessons I'm going to be taking you on. So let's get down to the main business. So if they ask you to define indices, the question is, what do you say? It's very simple. Just go straight to the point. Now, this is it very first. You should know that indices and your index, two of them are same. Indices is plural, but the singular form of indices is called your index. So how do you define index? Index or par or exponent, the three of them means the same thing. So when I say what is an index or what is your par or what is your exponent, the three of them, they are the same. So your index or your par or exponent show how many times a quantity is repeatedly multiplied by itself. So the number of times a quantity is repeatedly multiplied by itself is what we call your index or par or exponent. Let me show this to you very fast. Now look at this. Let's say we have something of this nature. You can see from here that you have your 5 times 5 times 5 times 5. Now the question is, how many times has 5 repeated itself? 5 has repeated itself. That's your 4 times. That's 5 raised to the power of 4 multiplied by 6 has repeated itself. How many times? That's 3 times. That's 6 raised to the power of 3. So this is the way we present your index or your par or your exponent. Are you with me? Now that you get that, very quickly you must notice that your index, like I've said, index is singular, meaning if index is singular, what will indices now be? Indices will be what? Your plural. So how are they represented? Your indices is represented in this form. Your y is equal to a raised to the power of n. So if I have my y is equal to a raised to the power of n, what does this mean? What is the meaning of the n there? What is the meaning of the a there? Now this is very simple. Take note of this, that where your n is the index, n there is the index or your par or your exponent, and a there is nothing but the base. When you hear a, what is a there? A is the base. Are you getting me now? So let's say, okay, let me say c is equals to your x raised to the power of b. Now the question is this: what is our b here? B here is equal to the what? The index or the par or the exponent. X there is the base. It's as simple as that. If you understand that and you are truly sure you do understand it well, follow me as we look at the laws of indices. Now hold on a bit. As far as 100 level is concerned, right, for both first and second semester, your complete series of classes, including your practicals, everything from beginning to the end is in the LearnLift app. All you have to do is just march down to your Play Store or App Store and download the LearnLift app, and then you're going to have access to every singular class. So just move down to tertiary, click on tertiary plan, where you are going to see all your classes as far as your 100 level is concerned. And guess what? Your video lessons are there, your CBT is there, you have access to your past questions, you have access to your notes. Very, very important. Man, this semester you must do well. Anyway, let's proceed quickly as we march down to our class and continue our class. Enjoy. Now, what are the laws that govern indices? Now, this is very fast. There are a lot of laws. Let's look at them one after the other. Law 1. The law 1 for your indices is very simple. Now, let's say we have something of this nature, your a raised to the power of m times your a raised to the power of n. What is it going to give us? A lot of people like calling this your product rule. Either you call it your laws or your rules of indices, they are the same. A lot of people like calling it product law or product rule. Some like calling it addition law or addition rule. They are same. Now, what does this mean? It means, now look up, what you check is this: anytime the base are the same and then what is binding them is multiplication, what do? Pick one of the base and then add the par together. So this is going to give us your m plus n. But on the ground that their base, they are the same. If the base are not same, will this law hold? It's not going to hold. Let's say we have 2 raised to the power of 2 multiplied by 2 raised to the power of 3. Now the question is, what become the answer? This is going to give us, the first question is this: are their base same? Yes, base is same. What is the base? The base here is 2 and 2. They are the same. Pick one, that's 2. What do we do? It's going to be 2 plus add the power, that's 3. And that's going to give you 2 raised to the power of 5. And what's 2 raised to the power of 5? You should know the answer. Now this is it. 2 raised to the power of 1 is 2. 2 raised to the power of 2 is 2 times 2. And that's 4. 2 raised to the power of 3 is 2 times 2 times 2. And that's 8. 2 raised to the power of 4 will give you 16. 2 raised to the power of 5 is going to give you 32. Are you getting it now? So anyway, you see 2 raised to the power of 5 is 32. 2 raised to the power of 6 is going to be how many? 64. Now these are the constants you're going to be seeing in your exams. Are you there with me? Very, very important. Now, what is 2 raised to the power of 5 from the question that we're given? 2 raised to the power of 5, that's going to be 2 raised to the power of 5. That's how many? 32 become the what? Final answer. But now, let me ask you a question. What if, okay, they give us something of this nature? Let's say your 2 raised to the power of 3 multiplied by 3 raised to the power of, let's say 3 as well. Now, is it true that this automatically will give me this base here? The question is that the base first, are they same? No. What is same here is their power. The power there that we have there is your what? Your 3 and 3. That's what is same. So this 3 and this 3, they are same. But the base 2 and 3, they are not same. That means this law 1 is not going to hold. Are you there with me? Let's look at, again, what is the first law that governs indices? We said that the first law is check out their base. If their base are same, and what is linking them is multiply. What do you do? Pick one of the base and then add their powers together. Look at the second law very fast, law 2. In the law 2, now what happens here? Look at this quickly. We have a raised to the power of m multiplied by a raised to the power of n. What is it going to give us? The first question is this: are their base same? Yes, base are same. So if the base are same, and what is binding them is division sign. What do? You pick one of the base and then you subtract the power. That's going to give you a raised to the power of m minus n. Now let me ask you a very simple question. Let's say b raised to the power of x divided by b raised to the power of y. What's the answer to this? Are their base same? Yes, b and b, they are same. Pick one of the base and that's b. What do you do? Subtract the what? The power. What do we have there? X minus y. Okay, let me shock you with this. Let's say we have something of this nature. Let's call it your 2 raised to the power of 2 divided by 2 raised to the power of 5. Now, what is the answer going to become? It's different from 2 raised to the power of 5 divided by 2 raised to the power of 2. You are going to get 2 separate answers here. Okay, let's try this. Let's say this is 1 and then this is 2. Let's solve 2 first and see what it's going to become. If we are solving 2, that's going to give us 2 raised to the power of 5, right? Their base are the same. Subtract the power, that's going to be 5 minus 2, and that's going to be 2 raised to the power of 3. That's what we're going to have there. Now, 2 raised to the power of 3, what's the final answer? That's going to give us 8 as our final answer. But if I come down to this guy here, it's a different thing in the first one. That's going to give us your 2 raised to the power of, now, are their base same? Yes, base are the same. But we have divide here, right? What do you do there? Subtract the power. And that's going to be 2 minus 5. What is 2 minus 5? That's going to be 2 raised to the power of minus 3. And what's 2 raised to the power of minus 3? This is another law here. Now, as we move, I'm going to show this to you. But this is the same thing as your 1 all over 2 raised to the power of 3. Don't worry. And that's going to give us 1 all over 8 as the final answer. Are you seeing it now? So one is giving us 1 over 8. The other one is giving us 8. You see that they are 2 different things. For law 2 to hold, what will happen then? We said that if their base are the same, pick one of the base, and if you have divide binding them, subtract their power. That's what happens here. Now, I'm going to proceed the other laws in another class so that it will not be too lengthy, so that you can follow me very, very, very well. See you in the next class. Enjoy. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye. Bye bye.